Let us look at question 3 in the assignment. At the end of 1995, the population of Urbis was 46,650, and by the end of 2000 it had risen to 54,200. On the assumption that the populations at the end of each year form a geometric progression, find the population at the end of 2006 and the year in which the population reaches 100,000. So the nice assumption that they give us here is that the populations at the end of each year will form a GP. So let's take a look at what that GP will look like. U1, our first term in our GP, is going to be 46,650, and this is the population at the end of 1995. Just while we're here, it's useful to note that n equals to 1 corresponds to the year 1995, and this will help us out later on. Specifically, I want to find out now for 2000, what year is that going to be? Well, if n equals to 1 is 95, n equals to 2 is 96, n equals to 3 is 97, n equals to 4 is 98, n equals to 5 is 99, n equals to 6 is going to be the year 2000. So that means that U6 is going to be 54,200. But we are assuming that this is a geometric progression, right? So U6 is going to be U1 times our common ratio to the power of 5. And this allows us to try and find out what our common ratio is. So it turns out that r to the 5 is going to be 54,200 divided by 46,650. Or if we simplify that fraction, 1084 over 933. So what is r? R is just going to be then the fifth root of 1084 over 933. So what can we do? We want to find the population at the end of the year 2006. Well, 2006 is the same thing as saying, if you think about it, n equals to 6. 6 years later than the year 2000, right? So we just add 6 on to our n as well. So what is U12? U12 is going to be U1 times r to the power of 11. So what do we get? This is going to be 46,650 times 1084 over 933 to the 1 over 5 to the power of 11. So 11 over 5 in the exponent. And if we work this out, this is approximately equal to 64,900, rounding to 3 significant figures. Note, because they didn't tell us the level of accuracy they were after in this question, we round to 3 significant figures. Good. So, part 2, the year in which the population reaches 100,000. So, what does that mean? That means I want to find UN that is greater than or equal to 100,000. Right? So if you recall, my r is equal to the fifth root of 1084 over 933, and U1 is equal to 46,650. Not sure if I'll need them, but I'll just leave them up there anyway. Well, actually, it turns out I do need them, because I know that this UN is going to be AR to the n minus 1, and I want that to be greater than or equal to 100,000. So what does that give me? That tells me that 46,650 1084 over 933 to the power of n take 1 over 5 has to be bigger than or equal to 100,000. So this is kind of messy, and our variables in the exponent, so we're going to take a ln on both sides. So taking logarithms on both sides, I get ln of 1084 over 933 to the n take 1 over 5. And then I'll just have divided this through first. So this is less than or equal to the ln of 100,000 over 46,650. So now, because this is an exponent, I can bring the a logarithm, sorry, I can bring the power down the front. That gives me n take 1 over 5 ln 1084 over 933 has to be bigger than or equal to ln of 100,000 over 46,650. So what can we say about n? N has to be bigger than or equal to 5 times, sorry, don't want to make it too big, but 5 times ln of 100,000 over 46,650 over ln of 1084 over 933 plus 1. And if you look at this mess, that actually means that n has to be bigger than or equal to 26.4 about, which means that I have to choose n bigger than or equal to 27. I'm not rounding to the nearest integer. In fact, the nearest integer is 26, but I'm rounding to the nearest integer above 26.4. In that case, that's 27. So if n is equal to 27, what does that mean? It means it's the end of the 27th year. So that means it's actually going to happen in the year 2021. And we always answer in words because they ask the question in words. And that is the end of the assignment.